Greetings, I'm Dev the developer.
And I'm Glitch, ready to expand our operational parameters for the mid-tier hardware. Let's see how much horizontal room we can exploit.
The mobile layout is done. Now we write the first media query and shift to a 2-column layout for tablets. This is where Grid shows its true potential. Alright, mobile is locked in. Every section stacks in a single column and the grid takes up the full width. Now, we can level up.
Level up, I like that framing. Where do we go from single column chaos?
2 columns. When the screen gets wider, we stop stacking content and a side on top of each other. We put them side by side. That is the tablet layout.
How do we decide when wider kicks in?
That's the breakpoint. We use 40M. At 16 pixels per M, that's 640 pixels. Think about what lives around that width.
Like what? Give me examples.
iPad mini and portrait is 768 pixels wide. That's past 40M. Amazon Fire tablets hover around 600. Landscape phones are often right there too.
So 40M is not tablet exactly. It's more like anything wide enough to handle 2 columns without looking crammed.
Exactly. And we use M instead of pixels on purpose. If the user bumps up their font size in the browser, the breakpoints scale with them. Pixels don't do that.
Responsive to user preferences, not just screen hardware. That is more considerate than I expected from CSS.
CSS has its moments. Alright, before we write anything, let's review the mobile grid we have. Switch to styles.css, look at the .grid rule. We have 10 equal columns, each 10% wide, and 5 explicit rows, a header, nav, and content, a side and footer.
And on mobile, each section spans all 10 columns. Column 1 to 11. The grid is there, it just isn't doing any horizontal work yet.
Right. The grid infrastructure is already set up. The media query doesn't rebuild the grid from scratch. It just reassigns which cells each element occupies.
That is genuinely clever. The bones stay the same. We just rearrange who sits where.
Now, a question before I show you the code. Why do we use line numbers like 1/8 instead of named areas with grid template areas?
I was going to ask that. Grid template areas looks cleaner in examples. Why not use it here?
Named areas are great, but they require you to define the full template string on the parent every time the layout changes. That means rewriting it at each breakpoint.
So you would need a new grid template areas string for mobile, another for tablet, another for desktop, each one spelling out the full grid.
Exactly. With line numbers, we only touch the children. The parent grid stays put. Each breakpoint just overrides the column and row assignments on the elements that move.
Line numbers are more surgical. Named areas are more readable when you have one layout. Line numbers scale better when layouts shift significantly.
That's a fair summary. Okay, let's write the media query. Go to the bottom of the style sheet. We'll add the @media block now. The media query wraps everything. Min width, 40M. Anything at or above that width gets these styles layered on top of the mobile base.
Min width means at least this wide, so mobile stays below 40M and tablet gets these overrides starting at 40M. That's the cascade working.
Exactly. Mobile first means the base styles cover everything. Each media query adds or overrides for larger screens. You never fight the cascade, you use it. Now the big one, content and aside. On mobile, they each span 10 columns. On tablet, they share row 3 side by side. Content gets 7 columns, aside gets 3.
7 and 3 out of 10, that's 70% for main content, 30% for the sidebar. Why that ratio?
Aside is supplementary. Author info, links, extras, it doesn't need equal billing. 7/30 split gives the content more room to breathe without the sidebar disappearing.
3 columns at 10% each is 30%. 7 columns is 70%. Clean math. The 10-column grid makes these ratios easy to hit.
That's exactly why we set up 10 equal columns at the start. It's a flexible system. Want 60-40? Use 6 and 4. Want 75-25? It's a little trickier.
10 columns do not divide evenly into 4 equal parts, but 12 columns would. That's why many grid frameworks use 12. More divisors, more layout options.
Right, Bootstrap uses 12. Our 10 column setup is simpler for learning and still covers the layouts we need. Alright, let's write the content and aside rules. Content goes from column line 1 to line 8. That's 7 tracks. Aside goes from line 8 to 11, both on grid row 3.
Wait, column lines 1 through 11, but we said 10 columns. Are there 11 lines?
Great catch. Yes, 10 columns creates 11 vertical lines. Line 1 is the left edge. Line 11 is the right edge. Lines are between the columns, not the columns themselves.
So grid column 1/8 means start at line 1, end at line 8. That spans columns 1 through 7. 7 columns. The math resolves.
Exactly. And the aside. Line 8 to 11 spans columns 8, 9, and 10. 3 columns, 7 plus 3 equals 10. Full width coverage.
And border top, none on the aside. On mobile, we drew a horizontal line above it to visually separate the stacked sections. At tablet, that border would look wrong.
Right. The visual separator makes sense when aside was below content. Now they're side by side. The border top would slice across the sidebar at the wrong spot.
Secondary intelligence unit assumes its designated position alongside the primary content channel. Lateral deployment confirmed. Separator protocols terminated.
I love that the sidebar finally getting its own column triggers a tactical readout from you.
All structural realignments warrant documentation. I stand by that.
Fair enough. Now, I want to pause here and compare this to float-based layout. The original Dragon's Den used floats for its 2-column layout. Do you remember that?
I remember. Float the content left, float the aside right, give them explicit widths, pray that clearfix works. It was fragile.
Why was it fragile?
Floats take elements out of flow. The parent collapses unless you add clearfix hacks. Heights had to match or backgrounds would not line up. Lots of workarounds.
And with grid?
Grid items stay in flow. The parent knows their height. No clearfix. No width percentages that break when you add padding. The grid handles the math.
And changing the layout at a breakpoint? With floats, you had to go from stack to side by side. You had to undo the float, reset the width, and clearfix to the container.
With grid, we just changed 2 grid column values. The framework absorbs the transition. No undoing, no clearing, no praying.
That's the biggest win. Responsive layout with grid requires less code and less cleanup than float layouts. Grid was built for this problem. Floats were not.
Float was designed to let text wrap around images. It got repurposed for layout. Grid was designed for layout. Using the right tool changes everything.
Exactly. Okay, next, the nav. On mobile, nav items are stacked vertically. On tablets, we have enough width to put them in a horizontal row.
The nav items are list items. We float them left to line them up. The container needs overflow hidden so it does not collapse.
Wait, we're using floats here? Didn't we just talk about how floats are trouble?
Floats are still appropriate for nav items inside a container. The nav is a flex-worthy candidate too, but we're keeping it simple and consistent with the lesson.
Good point. We're using floats in a controlled way here, inside a small contained element, not for the whole page layout. That's a reasonable use. Let's go ahead and write it. Float left on the list items. Overflow hidden on the nav unordered list to contain the floats. And we clear the border that stacked them vertically on mobile.
And width auto. On mobile, we did not set a width, but nav items might pick up inherited widths depending on the browser. Auto makes the item shrink to content width.
Right, and padding changes too. Mobile used 0.6 em vertical by 2 rem horizontal. Tablet gets 0.7 em vertical and 1.2 rem horizontal.
Slightly taller tap targets but narrower horizontal padding. On a horizontal nav, you want breathing room between items, but not so much the bar feels wasteful.
Now, display inline block on the link. On mobile, it was display block so the full row was clickable. Inline block keeps it clickable, but lets it sit in the float flow.
Block takes full width, inline block takes only what it needs and respects padding and margin. Better fit for a horizontal nav item.
Okay, here's something I want to dig into before we move on. Spacing in grid. We haven't used gap in this project yet, but it's worth understanding.
Gap is the spacing between grid tracks. You can set it on the grid container. It applies between rows, between columns, or both.
3 properties: gap, which is shorthand, row gap, which only affects the space between rows, and column gap, which only affects the space between columns.
So if you write gap 1 rem, both row and column spacing get 1 rem. If you write gap 1 rem 2 rem, the first value is rows, the second is columns.
When would you want them different?
A card grid, you might want more vertical space between cards as you scroll, but tighter horizontal space so the cards feel like a cohesive row.
Or the opposite, magazine layout with tight rows but a clear gutter between article columns so your eye doesn't accidentally jump between columns while reading.
Row gap and column gap let you tune each dimension independently. Gap is the shorthand when you want the same value everywhere.
In our Dragon's Den layout, we're handling spacing with padding on the individual elements rather than gap on the grid. Either approach works, but they behave differently.
Padding lives inside the element, gap lives outside it between elements. Padding affects background color, gap creates empty space between grid areas.
Good distinction. With our teal header and red nav, if we use gap, we get a sliver of that body background between them. Padding avoids that.
The architectural choice of gap versus padding carries visual consequences that must be modeled before implementation. I find this fascinating.
I'd just say, think before you code, but yes, that's what you mean. Okay, last piece, the header image.
On mobile, object position is set to right. That shows the right side of the banner image when it's cropped to fit the tall mobile header.
On tablet, the header is wider. We want to show the left side of the banner instead, so we override the object position to left inside the media query.
The image itself doesn't change. The picture element handles which file loads. Object position just changes which part of the image is visible in the frame.
An object fit cover is already set on mobile. That makes the image fill the container without distorting. Object position then says which part to center on.
Cover fills the box. Position determines focal point. Together they give you art-directed cropping through pure CSS, no JavaScript, no image editing.
Okay, let me also add a header text-align override here. On mobile, we had text-align right. On tablet, we still want that, but let me be explicit about it. Wait, I typed center, but I meant left. On tablets, we want to show the left side of the banner. Let me fix that.
Center is not wrong per se, but the banner image has interesting content on the left. Left makes the design intent clear and consistent.
There. Rewrote the whole file so object position is correct. Left, not center. This is why you check the browser before you move on.
The difference between center and left is invisible in the code. It only surfaces when you render the page. Visual verification is not optional.
Alright, the full tablet media query is now in place. Let's look at what we actually built before we preview it. Header and footer unchanged, still spans all 10 columns.
Nav still spans all 10 columns horizontally, but the items inside float left now so they line up in a row instead of stacking.
Content moves from full width, row 3, to columns 1 through 7, row 3. Aside moves from full width, row 4, to column 8 through 10, row 3.
Row 4 disappears in the tablet layout. The aside no longer needs it. It slots into row 3 alongside content. The footer climbs up to row 4 automatically.
Wait, Actually, the footer is still assigned to row 5. In mobile-based styles, with the aside gone from row 4, we have an empty row.
The row is auto-sized. An empty auto row collapses to 0 height. Visually, the footer appears directly below the content and aside. No visible gap.
Good. So the grid handles the empty row gracefully. We could also reassign the footer in the media query to row 4, but the collapse behavior covers us here.
Pragmatic, the grid's implicit behavior works in our favor. We document it, we don't fight it.
Let's go ahead and open the browser and look at the dev tools. So we can do some resizing and see how we switch from mobile to the tablet view. We can also look at it on some different devices. For example, on a phone versus an iPad. There it is. Nav section horizontal across the top. Content and aside are side by side. And the banner image is showing the left side now.
All structural parameters achieved. Layout integrity confirmed across the 40M threshold. The grid has executed its mandate with precision.
It's just a working layout, but I'll allow it. Now shrink the viewport back and forth between different sizes and watch it snap back to mobile. That is responsive design. One style sheet, 2 layouts, no JavaScript. The browser does the switching based on viewport width automatically.
Mobile First Plus media queries, the base is lean. Enhancements are layered. Devices get exactly the complexity they can handle.
Let me also say this, 40M is not a magic number, it's just a guideline. If your content works better at 35M or 45M, use that.
Breakpoints should be derived from the content, not from a list of popular device sizes. Set the breakpoint where the layout actually starts to look wrong.
That's a principle worth remembering. Content-driven breakpoints, not device-driven. The content tells you when the layout needs to change.
37M, 42M, 50M, whatever your content requires. M units make those choices consistent across user font size preferences.
Alright, let's recap the tablet breakpoint rules we added. Inside the 40M media query, we have 5 rule blocks. Content, aside, nav unordered list, nav link list item, nav list item A, header, image, logo.
That's 7 blocks, not 5, but yes, each one overrides specific properties from the mobile base. Nothing is duplicated that doesn't need to change.
I miscounted, which is kind of the point. The media query is targeted and minimal. We only change what needs to change. Everything else inherits from mobile.
Progressive enhancement, minimum override principle, efficient use of the cascade, all properties of a well-structured style sheet. I approve.
High praise. Coming up next, we'll tackle the desktop layout. That's where we add a third column for the nav on the side and cap the max width on the whole layout.
Desktop 3-column configuration, constrained width, centered layout. The structural complexity increases. I am prepared.
Before that, your job. Build this tablet breakpoint yourself from scratch. Start with just the mobile styles and add the media query. Check it at the iPad mini size.
Replicate the grid column assignments, the nav float rules, and the image position override. Then experiment. Try a 60-40 split instead of 70-30.
Or try named areas with grid template areas. Set up the full tablet string on the parent and see what that looks like compared to what we did with line numbers.
Compare the two approaches yourself. See which feels more maintainable to you. There is value in the experiment beyond the answer.
Don't just watch it, do it.